So it's open. All right, so we're gonna remove B. So then, what do we know about H? H equals the sine of A. And the sine of A, remember, that's not special in any way. You just put it into the calculator. It's going to be some decimal, right? All right. So now, what's our other equation? So we need to get rid of that H, the A, so that we have H equals. So this one we have H equals A times sine of B. All right, so since they both equal H, since B times sine of A equals H and A times the sine of B equals H, since they both equal H, then what do I know about the two right sides? They're congruent, they're equal to each other. This is a multiplication in here. All right, so it says complete the following statement. Sine of A over blank equals sine of B over blank. So I need to get something in the denominator, right? So if I just divide this side by B, what do I have to do to the right side? Divide by B, right? What my B's here cancel. Are we okay so far? Alright, so I want to divide this side by A. My A's cancel here, right? But if I divide that side by A, what do I have to do to the other side? So sine of A over A equals sine of B over B. And that we just get that from dividing those side lengths out on either side. And what's nice there is now we have a nice proportion, right? And we can just pop in the information that we know to get that. Now that only works though if we're dealing with an altitude that's breaking our bigger triangle into two smaller ones. How are we feeling about that? You followed along, but you're like, please don't ask me to do that all by myself. Okay. All right. So what we just did is we proved the law of sine, and what the law of sine says is that if we are given a triangle ABC, then the sine, and we have an altitude, we have it cutting into different. We have a right triangle, essentially. We have sine of angle A over side length A equals the sine of angle C over side C. And then we have sine of angle B over B equals sine of angle C over C. And so then we have, so this right here is the law of sine. Sine of angle A over side A equals the ratio of sine of angle B over side B equals the sine of angle C over side C. So if you know one angle and two sides, you can find that missing angle. If you know two angle measures and one side, you can find the missing information without having to really go through and do all your SOHCAHTOA type stuff. So it's giving you another option. So I can see the excitement on your faces. All right, so let's look at example A. So fire spotters at stations located at A and B notice a fire at location C. What is the distance between angle A and the fire? So the fire is at C. So we'll draw our little fire there. So there's my fire. So I really originally applied for the math for that art position, but you can have too much skill. All right, so we have our fire at sea. People at fire station A see it, and they're looking at it at an angle of 42 degrees, and the people at station B see it at an angle of 44 degrees. And we know the distance between station A and B is 15 kilometers, and we want to figure out how much fuel does station A need to put in their fire truck to get to the fire, and how much fuel does the fire truck need at station B to get to the fire. Well, no, because you don't want too much gas. We want the exact. Maybe it's an airplane. Maybe it's the airplane. They're flying the plane out there, and you want to be able to get as much water and fire retardant chemical stuff that they don't into the plane. So you want just enough fuel to get there and back, so that you can maximize your fire. Just enough. All right. So step one, we want to find the measure of angle C. So if we know angle A and angle B, can we find angle C? Yes. So what is angle C? All right, so there it says 94 degrees. Do we all agree? Or are we accepting? All right. So, I guess I do show their work. So 180 minus 42 minus 44 equals 94 degrees. So if springboard's correct, then that's it. I don't trust springboard, so I wish somebody would check that.
I don't trust Garrett.
All right, so now is this a right triangle? No, but because we can use law of sines, because if we draw the altitude here, then we have those two right triangles, right? And we just showed that with those two right triangles, this proportion will work. So the law of sines says that the sine of angle B over side B equals sine of angle C over side C. So we have sine of 44 degrees over B, which is what we want to find, equals the ratio of sine of 94 degrees over 15. So can we solve this proportion?
Yes.
Yep. So to get B by itself, they cross multiply. So B times sine of 94 equals sine of 44 times 15. So cross multiply, and then divide both sides by sine of 94 to get B by itself. And so 15 sine 44 divided by sine of 94 is about 10.4 kilometers. All right, so are you ready to do one together? All right, let's do. All right, so now we're gonna focus on boaters. Okay. So boaters are located at points A and B, and then there is a lighthouse at both C. So what is the distance between the boater located at point B and the lighthouse? Round to the nearest 10. All right, so let's figure out what angle C is first. All right, so I have one vote for 77. Let's make sure I got 2 votes. So we did our math. So in order, just to kind of refresh our memory later, because I know all of you are going to be fast forwarding to watch this example at some point. So to find angle C, we took 180, which is the magic number for all triangles, right? They all have 180 degrees, minus 48 degrees, and that gives us 132 degrees, and then we're subtract 55 degrees. And that gives us 77. All right, so now we're going to use law of sines. So how do we do law of sines for this one? So we have sine of angle A over A equals sine of angle B over B equals sine of angle C over C. So if I want to find side A here, what would that proportion look like? What's the only side that we're given? Side C here, right? So that means that regardless if we're finding side A or B, we have to have sine of, because it's across from angle C. This is side A, that's across from angle A. This is side B, that's across from side B, angle B. So we have angle C and we have side C. So this is going to be half of our proportion, regardless if we're finding side A or B. Because that's what we have, that's the information, the complete information that we have, right? So in for C, what are we going to put? What's our angle measure for C? And our side for C? Alright, so now, I said I want to find this one. So what's the angle for that? Which is 48, right? And then A is what we want to find. So now we have our proportion. You guys know how to solve proportions, right? So cross multiply. So we're going to have A times sine of 77. Is sine of 77 anything special? No. Make sure your calculator is in degrees. And you're going to push the sin button and then the number 77 and push enter. Some of your calculators are reversed and you push 77 and then the sin button, right? Alright, so then we should get a decimal. What do we get? 0.97. And that equals A, right? And then we're going to take the other side, or that 0.97 times A, and then we're going to take 1.5 times sine of 48. What is it? 1.11? Oh, for A? Okay, so that's, so 0.97A equals 1.11. Alright, so now is A by itself? No, so what do we have to do to get A by itself? Right, because this is 0.97 times A. So we need to divide both sides by 0.97. And so now, is our answer going to be smaller or bigger than 1.11? We're dividing by something less than 1, so we're going to get bigger. So A equals, so A equals 1.14. So boat or B is 1.14 kilometers from the lighthouse. All right, so now let's find B. Do we have a right triangle? No. You have two right triangles. So if you know the altitude, you can use, if you look for your altitude, you can use your SOHCAHTOA to find the altitude and then use the Pythagorean theorem. No, but I want us to find B. So let's find side B. All right, so let's find B, side B now. So how's this gonna look? Okay, that's not too bad, right? so I should see everybody writing. We've done that, so now all you need to do is to pop in some numbers. I'm gonna walk around and stare.